So now moving with the next question, that is question number 21. The force between two charges 0.06 meter apart is 5 Newton. So you're not given the charges. Some charges are there which were separated by a distance of 0.06 meters, and the force between them is acting is 5 Newtons. If each charge is moved towards the other by 0.01 meters, then the force between them will become. So let us try to understand the same clearly. So first one, the force between the two charges which are separated by a distance of, how much distance they have given, children? Separated by a distance of 0.06 meters. Then the force acting between them is given as 5 Newtons. Let this be Q1 and this be Q2. Similarly, case 2, when the same two charges, okay, is moved towards the other by 0.01. So earlier they were 0.06 meters. So this one is moved. Yes. So what is there means this charge is moved a distance 0.01 meters, and when this charge is also moved a distance of 0.01 meters. Then when they are moved a distance together towards each other, this will reduce a distance of 0.01 and this also reduces a distance of 0.01. So altogether the new distance will be 0.06 initial distance minus first sphere reduces by a distance of 0.01, second also reduces a distance of 0.01. So finally it was found to be 0.06 minus 0.02 and the new distance is found to be 0.04 meters. Charges remains the same. Okay, as the distance of separation changes, the force between them also changes, and let us find it out. Let us name it as some F2. So you have to find out the new value F2. Children, as we know that the old value F1 is equals to K times of Q1 Q2 by R square. Okay. And R square is 0.06 whole square and its value is given as 5 Newton. So clearly the value of K Q1 Q2 is equals to 5 times of 0.06 whole square, and K Q1 Q2 is found to be 5 into 0.36. 0.6 square is 0.36, or K Q1 Q2 is found to be 1.8. So what is the value of K Q1 Q2, children? It is found to be 1.8. That's it. So now let us find the new force. So F2 is equals to K Q1 Q2 by new distance square. What is the new distance square? 0.01 whole square. But what is the value of K Q1 Q2? I already found it as 1.8 upon 0.04 whole square is found to be 0.16. So this is all about 180 upon 16. Okay. So simplifying further, you get 8, 94 and 45. Hence 45 upon 4, after further simplification, it gives you the result as F2 is equals to 2 and 5. 11.25 Newton. Hence the correct option must be option B, that is 11.25 Newtons. Clear, children? So, well, now moving to the next question, that is 22nd. Here we go. Two charges each equal to 2 microcoulomb are 0.5 meter apart. Excuse me. So what is given, children? Two charges each equal to 2 microcoulomb are separated by 0.5 meters apart. If both of them exist inside a vacuum, then the force between them is. So charges is given, it was given that it is set in vacuum. Force. So the formula for force F is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square, or simply K Q1 Q2 by R square, where the value of K is taken as 1 by 4 pi epsilon naught. Substituting all the values, K in air means epsilon naught and its value is found to be 9 into 10 power 9. Each equals to 2 microcoulomb. Microcoulomb means 2 microcoulomb means 2 into 10 power minus 6, one charge. Similarly, another charge also 2 into 10 power minus 6. Microcoulomb, in order to convert into coulomb, we have to multiply with 10 power minus 6. Two such charges, so 2 times upon distance of separation is 0.5 whole square. That's it. So simplifying this, we get it as 9 into 2 multiplied with 2 is 4. 10 power 9 and minus 6 is 10 power 3. 10 power 3 and 10 power minus 6 is 10 power minus 3 whole upon 0.5 whole square can be written as 0.25. So simplifying this further, we have 9 fours 36 upon 25 upon 100. Okay, that 100 will go up means 10 power minus 1. Okay. So this value, after simplification, it will be found something like this. F is equals to 36 upon 25, okay, into 10 power minus 1, or I'll write it like this, or this can also be written as simplifying. This will be something like 0 times, okay, I'll just write it. Now you can understand well. So value of this is given by 25, 1 is, you are getting it, and left with 36 and 25, 11, okay, 11, 110, 110 means 4 times is 100, 144, so 1.44 approximately into 10 power minus 1 can be written as 0.144 Newton. So just go through this, children. 36 when divided by 25, you'll be getting it as 1.44 into 10 power minus 1. Solved, you'll be getting it as 0.144, and hence the correct option is option C, that is 0.144. So moving ahead with the next question, children. Okay, which of the following statements is true? So there are, here you have given 4 options and you are asked to find out which one is correct. The electric field due to a point charge can be same at 2 different points. So what is the first one? Electric field due to a point charge can be same at 2 points. No, not absolutely. Because if you consider a charge, then from this charge, the electric field lines will be moving positive charge if I consider something like this moving away. So what they were asking you is to find that at 2 different points, can electric field will be same? No, because it changes normally from point to point. So it cannot be possible. The electric field increases continuously as one goes away from center of a solid uniformly charged sphere. No. So as we move away from the charged sphere, the electric field intensity decreases, does not increases. The electric lines of force of the electric field produced by the static charges form closed loop. I have already discussed that electric charge never forms a closed loop. Electric field lines never form a closed loops. Now the last one, electric lines of force due to a positive charge is diverging. Diverging means moving away. If you consider a positive charge, the electric field lines always moves away from the positive charge. So they diverge from the positive charge. Hence, the correct option is option D, that is electric lines of force due to a positive charge is diverging. Now, moving to the next one, that is 24th question. The Coulomb's electrostatic force is defined for. So, Coulomb's force defines that F is equals to, or F directly proportional to Q1 Q2 by R square. So, how many charges are we considering? 2 charges. So, the Coulomb electrostatic force is defined for. Coulomb's electrostatic force is defined for 2 spherical charges. Is it at rest, in motion, point charges in motion, or 2 point charges at rest? Okay. So, generally we have considered that the Coulomb's force of attraction between the force of attraction and repulsion between 2 point charges. So, not sphericals. And are these 2 charges considered at rest condition or they are moving, motion? They are considered at rest condition. So, Coulomb's force of is always Coulomb's electrostatic force of attraction or repulsion between any 2 charges which are at rest is directly proportional to the product of the charges as well as the inversely proportional to the square of the distance between them. Hence, the correct option is option D. It is. Now, moving to the 25th, the law governing the force between electric charges is known as. What is that law, children? Just now we have discussed. It is Coulomb's law. Governs this forces between the electric charges. So, now moving to the next one, that is 26th question. It was given that the electrostatic force between 2 charges Q1 and Q2 at separation is given by F equals to K Q1 Q2 by R square. The constant K depends on the system of units only, depends on the medium between the charges, depends on both medium between the charges and the system, is independent of both. No. So, it depends upon system as well as also between the medium. So, not only. So, here only fails. Depends on both. Depends on both. Yes. This must be the correct one. That is, correct option is option C. It not only depends on this or not only depends on the. It depends on both the values. Okay, not independent. It depends on both the values. Hence, the correct option is option C. Depends on both the medium between the charges and as well as the system of units. So, now moving to the next question, 27. The electrostatic force between the protons is how many times stronger than the gravitational force? Children, one thing you always remember, children, we have 3 main forces, basic forces in nature. One is the gravitational force, the other is electrostatic force, and also the strong nuclear force as well as the weak nuclear forces. Okay. Among them, the strongest are the nuclear forces. Okay, and the weakest is the gravitational force, and the relation between the forces acting between them and compared to the electrostatic force to that of the basic force, that is gravitational force, is always 10 power 36. Hence, the correct option is option C, that is 10 power 36 times as compared to the gravitational force. This thing you need to know, children. So, now moving to the next question, that is 28. When a brass plate is introduced between the 2 charges, the force between the charges, what happens? Decreases, increases, remains same, or becomes 0. So, what is this plate? This plate this plate is made up of brass. Brass means a metal plate. So, whenever this brass metal plate is introduced between the 2 charges, whatever be the charges, whenever a plate is being inserted, then no doubt an opposite charge is induced in this. As a result, this the force between the charges, these two, again some charge is created, here also some charge is created. As a result, the force will be increased. So, whenever a metal plate is introduced between the 2 charges, it increases. So this principle is actually used in the capacitors. In the capacitor, the same is used, okay, between the two. So something is introduced. So it increases, children, to increase the capacitance or the force between the two charges. Now moving to the next question, 29. The charge Q1 exerts some force on a second charge Q2. If third charge Q3 is brought nearer, the force of Q1 exerted on Q2 remains unchanged. So this also we have discussed in the previous concept. There is no effect. The presence of the presence of third charge does not affect the force between the first two charges, which was discussed in the previous numericals. Hence, third option. Now, moving to the last question. Mark the correct statements. So, 4 options are given, children. So, one among them must be true. So, first one, a given conducting sphere can be charged to any extent. A given conducting sphere cannot be charged to a potential greater than a certain value. Maximum charge that can be given to a conductor depends upon the radius of curvature. Of course, maximum charge that can be given to a conductor depends upon the radius of curvature. Okay. So, correct option is option C. That is, maximum charge that can be given to a conductor depends upon the radius of curvature. Because formula depends for this is force is given as 1 by 4 pi epsilon naught Q1 Q2 by R square depends upon the radius of curvature. So, more charge means more accumulation means more amount, larger the spherical value must be there. Of course, so given conducting sphere cannot be charged to a potential greater than a specific value. Even that also proves same. So, with this we have concluded the concept worksheet and hence the electrostatics. So, children, just keep practicing. We have covered different numericals based on this. Okay, and keep practicing. Let us meet in the next video. Until then, take care. Thank you.